Hello and welcome to R&D Mathematics. Today we are going to learn about other types of equations. In our previous videos, we learned about quadratic equations and linear equations. Now let's see some examples of other things that can appear. X minus 3 square root minus 2 equals 0. Now normally we call something like this a radical equation. How do we deal with something like this? So we need to find the value of x. Now there are certain tips and certain things that you must remember. The first tip is actually isolate the term with radical sign. Isolate the term with radical sign. So that means in our case, this one, right? So if I take minus 2 to the other side, that's the way to isolate it. Now the next step that you need to do, raise to the required power in order to get rid of the radical sign. Now in this case it's just square root, so what I need to do, I need to raise it to second power. When I do that to my left hand side, I must do it to right hand side. So I get x minus 3 equals 4 and x equal 7. Simple as that. Now you have to be careful. Finally, you must check. The reason will be well understood when you see another example, because in this the reason actually in simple words we may be bringing unwanted solutions. Now in this case it's not the case, so when I plug x equals 7 here, I get 7 minus 3 minus 2. So 7 minus 3 is 4 minus 2, or 2 minus 2. Yes, that is 0. It's correct, right? And let's see another example. How about this? 2x plus 6 equals x plus 3. Now, the term involving radical sign is already isolated, so I just have to raise this to second power both sides. So I get 2x plus 6 equals, see, I need to put parentheses, so x squared plus 6x plus 9. And then taking everything to one side, I will have x squared, 6x minus 2x, that is 4x, 9 minus 6, that is 3. And I see factors x plus 1 and x plus 3. So my solutions are x equal negative 1 and x equal negative 3. Now we have to check. So x equal negative 1. Let's check this one. So when I put negative 1 inside my equation, 2 times negative 1, which is negative 2, plus 6 equals, see, my original equation, I shouldn't have done it like this. My original equation was this. So x plus 3. Again, I made a mistake. When you have your original equation, don't just square it there, next step, square it. There's a reason. You will understand it when you see the right example. So negative 1 plus 3. Let's see. 4, 2, and that's correct because 2 equals 2. Now let's check with x equal negative 3. When I put negative 3, I get negative 6 plus 6, which is 0. Negative 3 is 0. Yes, it is correct. 0 equals 0. So in this case, we have two solutions. This one. And let's see another example. How about this? Square root of 12 plus x equal x. And again, the term involving radical sign is isolated. Again, don't do the mistake that I did in previous example. So you square it in the next step. So I get 12 plus x equal x squared. Oh, if I take everything to left side, I get this. I see factors x minus 4 and x plus 3, right? So I get x equal 4 and x equal negative 3. Now let's check this one. when we check, okay, let's take x equal 4 first. When I take that, 12 plus 4, that is 16, equals 4. Yes, 4 equals 4, that's correct. This solution is correct. How about x equal negative 3? So when I put negative 3 in my original equation over here, 12 minus 3, which is 9, equals negative 3. Now we have to be careful here. Square root of 9 is actually 3. So 3 does not equal negative 3. This solution is wrong. Now, also sometimes some of you may be wondering, isn't square root of 9 is plus or minus 3? Well, actually, when we write square root of 9, this means we are only taking the positive or plus part. These things are explained in the very first videos. So if you want to write down plus or minus, this is how you write it. But when in this equation, we only take plus part, right? So no, that's not true. Now the reason. So our solution is just this. This is why we need to check. Now why this is happening? I told you we may be bringing unwanted solutions. Now let me explain this in a simple approach. Let's say x equal negative 3. Simple equation actually, yeah. There is nothing to solve. It's already been solved. X equal negative 3. Now if I square this, see, in our previous examples, we are raising it to the required power in order to solve it or in order to get rid of the radical sign. Now if I square it, I get x squared equal 9, right? Now if I solve this, then actually x squared equal 9, x squared minus 9 equals 0, x minus 3, x plus 3 equals 0. So x equal 3 or x equal negative 3. See, you started with only this, but now you have square in make it maybe we are bringing unwanted or additional solutions. That is the reason why you need to check. I hope that is understood. Now let's see more examples. How about this? 5 minus x cubic root plus 5 equals 0. Now the first step, term involving radical sign, you must isolate it. So this is negative 5. And then you have to raise it to, it's okay to raise it here, third power. So 5 minus x, and this guy is negative 125. Minus into minus into minus is minus. So when I multiply everything by minus sign, x minus 5 is 125. X is 130. Let's check. So when I put, let's check it here. So when I put x equal 130, 5 minus 130, so negative 125 plus 5 equals 0. Is that true? Let's see. So this guy right here, negative 125, 1/3 power. Now, even roots of negative numbers does not exist. For example, negative 1, 1/2. Or negative 1 square root. These does not exist. These bring complex numbers. But this one actually exists. This is negative 5. Because we are looking for a value. When we cubed it, we get negative 125. That is negative 5, right? So that one is negative 5. Plus 5, it's 0. And yes, that's correct. So this answer is valid. How about... Now it's not necessary for odd, for even roots to check this, but it's okay to, as in order to remember this, it's okay to always check. Let's see this example. So x minus 3 fourth root equals negative 3, and when I raise to fourth power x minus 3 remember parentheses here, equals negative into negative into negative into negative, which is positive. 3 into 3 into 3 into 3, 9 into 27, 81. So x is 84. And if you actually check it, you are going to get the answer correct. Now, let's keep doing more examples. How about this? Now, how about this kind of equation? X to the fourth minus 3x squared minus 4 equals 0. Now, in an equation like this is fourth power, right? Fourth power equation. This is not a radical equation, guys. See, the highest power is fourth power. The next highest is square. You don't see x cubed term. That is nice. Because of that, what you can do is you can actually substitute. So substitute. Simple substitution. How about u equal x squared? If I do that, x to the fourth is actually u squared. Minus 3 times x squared is u. Minus 4 equals 0. Now, this is a quadratic equation in u. So we have factors u, 4 and 1, x, u plus 1, u minus 4 equals 0. So I get u equals negative 1, u equals 4. But our u is x squared, is negative 1, x squared equals 4. From here I get x equal 2 and x equal negative 2. And from here I get only complex solutions, x equal I and x equal negative I. But if you are looking for real solution, these two are the solution. See, these are other kinds of equations. Now, this fourth power equation can be converted into a quadratic equation. But the reason is you didn't see any odd power or you didn't see any first power, this power. That's the reason. These are some techniques that I'm showing you in. How about another example? How about this? X to the negative 2 minus x to the negative 1 minus 12 equals 0. Now we can do the same thing. Now we can substitute u equal x to the negative 1. That brings u squared is actually x to the negative 1 squared, which is x to the negative 2. So x to the negative 2 now becomes u squared. X to the negative 1 is u minus 12 equals 0. Now this is a nice quadratic equation. So you have factors u minus 4n plus 3, right? Yes. So I get u equals 4 and u equals negative 3. But remember, u is x to the negative 1 or 1 over x. See, x to the negative 1 means 1 over x. So x to the negative 1, 1 over x equal 4, or x equal 1/4. And here 1 over x equal negative 3 or x equal negative 1/3. And these are the solutions. You only need to check when we have radical signs and also odd root powers. Not even for even root, but it's, as a practice, it's okay to check everything. Now let's see whether we have. Yeah, how about this? How about x to the x raised to 3 over 2 minus 3x raised to 1/3 minus 10 equals 0. Now, can you pause the video and think of a substitution that it makes to a quadratic equation? Okay, see, this guy actually, if you look, x 1/3 squared, right? And x 1/3 minus 10 equals 0. See, what if you do this substitution? This becomes u squared, this becomes u. This is, so we have factors. And it's going to be 5 and 2, right? 5 and 2, 10, and I can make 3. Can I? Negative, positive, yes. So u equals 5 and u equals negative 2. Now, u is actually x to the 1/3, that is 5. So x is going to be, in order to say, from here, x 1/3 negative 2. Now let me take both of them over here. So first one, x 1/3 equal 5. Now in order to solve for x, what you need to raise it to third power both side. Then I get x is 125, and from the second one, do the same thing, raise it to third power. I get x equal negative 8. Those are my solutions, negative 8 and 125. So I think that's a good number of other kind of, you know what, let's do another one. How about this? X cubed plus 2x squared minus, see, for some equations like cubic and fourth power, after quadratic equation there is no general way of solutions solving them, but depending on your equation we may be able to do some tricks. Now in this one, if you observe very carefully, again pause the video and try to do it with your knowledge. You can do it. Assuming you have tried, let's move on. See, if I catch these two guys, so if I rewrite it, if I rewrite it from here, I can pull x out, x squared minus 1, and from here I can pull 2 out, x squared minus 1. See, that's about experience. If you see the factors, now from these two, x squared minus 1 is common, so x plus 2. X squared minus 1 is x minus 1 into x plus 1. So we have nice three solution, x equal 1, negative 1 and negative 2. Okay, I think that's enough examples for other kinds of equations. So there is no particular way other than for, let me show you the radical equations. Radical equations, the first few things that you have to do, isolate the term with radical sign, then raise it to the required power. For example, let's say 2x minus 5, you had here 2 over 5th power. Then what you need to do, 5 over 2 power, right? And same with the other side, 5 over 2 power, like that. Reciprocal of that power, if you had 1/3, you have to raise it to third. If you have 7 over 2 power, you have to raise it to 2 over 7 power, like that, reciprocal of that power. And then you get something like this, and finally you check it. Okay guys, that's enough for today's video. Thank you.